वेलकम एव्हरीवन. स्टुडंट्स लिसन केअरफुली. आपला वेव्ह ऑप्टिक्स हा जो टॉपिक चालू आहे त्या टॉपिकवरती मी काही तुम्हाला क्वेश्चन्स आणि एक्झाम्पल्स सोडवण्यासाठी देणार आहे. ते एक्झाम्पल्स आणि क्वेश्चन्स सोडवण्यासाठी तुम्ही एक फिजिक्स विषयासाठी नोटबुक घालणं गरजेचं आहे व वेव्ह ऑप्टिक्स ह्या टॉपिक खाली ते एक्झाम्पल्स आणि दिलेले क्वेश्चन्स हे तुम्ही रेग्युलरली सोडवायचे आहेत. सो स्टुडंट्स, लेट अस स्टार्ट part 3 of the wave optics.
Students, in this video lecture, we will study which wave is called as a two-dimensional wave and which wave is called as a three-dimensional wave. Then, what is meant by a wavefront? Then, types of a wavefront. Huygens principle, construction of spherical and plane wavefront. Then, proof of laws of reflection and refraction on the basis of Huygens principle. Students, we know that when we drop a stone on the water surface, then transverse waves are generated along the water surface, and these waves move away from the point of disturbance in two directions along the water surface. Therefore, water wave is an example of two-dimensional wave. Also, in this image, we see the green circular lines, and these lines are called as wavefronts. Initially, we observe only first circular line. Then we understand that water particles on this circular line are at the same distance from the point of disturbance or from the center. Also, these particles are at the same displacement from the water surface. म्हणजेच हे जे पार्टिकल्स आहेत ते पाण्याच्या सरफेस पासून एकाच उंचीवरती असतील. ॲज वेल ॲज these particles move with the same velocity. That means ग्रीन सर्क्युलर लाईनवरचे पार्टिकल्स जे आहेत ते एकाच व्हेलॉसिटीनं मूव्ह होत असले पाहिजेत. ॲज वेल ॲज ऑल दीज पार्टिकल्स ऑन दी ग्रीन सर्क्युलर लाईन आर इन दी सेम स्टेट ऑफ व्हायब्रेशन्स. देन these particles on the green circular line are said to be in same phase. Therefore, definition of wavefront is the locus of all points of the medium which are in the same phase, and that locus is called as wavefront of a wave. म्हणजेच wavefront म्हणजेच हा सर्कलचा एक असा एक भाग आहे की ज्या भागावरती असणारे जे सर्व पार्टिकल्स आहेत ते पार्टिकल्स एकाच फेजमध्ये असतील. Students, then we see what is meant by a three-dimensional wave. A wave which travel in all direction away from the source and propagate in three dimensions. That means along x-axis, along y-axis, and along z-axis. And examples of three-dimensional waves are light waves and sound waves, because these waves propagate in all directions. That means लाईट सोर्समधून बाहेर पडणारी जी वेव असेल ती वेव किंवा लाईटचा जो प्रकाश आहे तो प्रकाश सर्व बाजूंना पसरला जातो. ॲज वेल ॲज आवाज जो आहे तो आवाज सर्व बाजूंना पसरला जातो. अँड इफ वी कन्सिडर दी सरफेस ऑफ दीज वेव्ज ॲट दॅट इन्स्टंट, देन इट इज स्पेरिकल इन नेचर. दॅट मीन्स ॲज लाईक अ बॉल सरफेस. Therefore, this wave is called as a spherical wave. Therefore, definition of spherical wave is a three-dimensional wave produced by a source which travel in all direction away from the source and propagate in three dimensions. And examples of spherical waves are light waves and sound waves. That means if we kept light source at the center of the ball, then on the surface of the ball, all waves from source reaches simultaneously because distance is same from the center to the surface so that all points on the sphere are in the same phase. Therefore, that sphere is a spherical wavefront, or locus of that sphere is a spherical wavefront. Therefore, definition of wavefront is as the locus of all points of the medium to which wave reaches simultaneously, so that all points of the medium on the locus are in the same phase. Then we see different types of wavefronts. There are three types of wavefronts. One is spherical wavefront, second is plane wavefront, and third is cylindrical wavefront. First we see in detail spherical wavefront. Spherical wavefront is obtained nearer the point source O. That means distance between source and wavefront is finite. Therefore, the radius of curvature has also finite value, as well as this wavefront is spherical in nature. And in this image, arrows indicates that light rays, and these light rays are convergent or divergent in nature. And example of spherical wavefront is that we get spherical wavefront nearer the candle. Then we see plane wavefront. When point source is kept at infinite distance, then we get a large spherical wavefront, and we know that small part of that large spherical wavefront is a plane surface, and that surface is called as a plane wavefront. Therefore, radius of curvature has infinite value, as well as this wavefront is plane in nature, and light rays are parallel to each other, as shown in this image. And example of this plane wavefront is that we get plane wavefront of light on the earth surface due to the sun. Then we see cylindrical wavefront. When linear source is kept at finite distance, that means nearer the tube light, we get cylindrical wavefront, which is cylindrical in nature, as shown in this image. Here, S is the linear source. Then difference between spherical wavefront, plane wavefront, and cylindrical wavefront is given in this image. Students, then we see Huygens principle. Huygens states that the principle for construction of new wavefront, and this principle is given in this PPT. According to this principle, each point on primary wavefront acts as a secondary source of light and emit secondary light waves in all directions, and envelope of these secondary waves after time t are the secondary wavelets, and these secondary wavelets travel with the speed of light only in forward direction, and envelope of these secondary wavelets gives the new wavefront. Also, according to Huygens principle, backward traveling of these secondary wavelets is not possible or ineffective, and this Huygens principle is given in this PPT. Then here we see construction of spherical wavefront by using Huygens principle. Consider a source of light. This source of light produces a primary wavefront AB, as shown in this image. Then consider PQRS are the 4 points on the primary wavefront AB. Then, according to Huygens principle, these 4 points PQRS acts as a secondary source of light and emit secondary waves in the forward direction. If v is the velocity of light, then in time t, each wave from points PQRS covers the distance equal to Vt. Then draw the semicircles around the points PQRS with radius equal to Vt, and these semicircles are the spherical wavelets. Then draw the tangential surface A', B' to all these wavelets at the points P', Q', R' and S'. And this tangential surface A', B' is the new secondary wavefront, which is also spherical in nature, and the arrows in this image indicate the light rays, and these light rays are perpendicular to the each wavefront. And this construction of spherical wavefront is given in this PPT. Students, then we see construction of plane wavefront by using Huygens principle, and that construction is as shown in this image. Consider a primary plane wavefront AB, and PQRS are the 4 points on the primary wavefront. Then, according to Huygens principle, these 4 points PQRS acts as a secondary source of light and emit secondary waves in the forward direction. If v is the velocity of light, then in time t, each wave from point PQRS covers the distance equal to Vt. Then draw the semicircles around the points PQRS with a radius equal to Vt, and these semicircles are the spherical wavelets. Then draw the tangential surface to all these wavelets at points P', Q', R' and S', and this tangential surface A', B' is the new secondary plane wavefront, and in this image also light rays are perpendicular to each plane wavefront. स्टुडंट्स, प्लेन वेवफ्रंटचं कन्स्ट्रक्शन जे आहे ते तुम्हाला रिटर्न फॉर्ममध्ये दिलेलं नाही. मात्र स्पेरिकल वेवफ्रंटचं जे कन्स्ट्रक्शन आहे ते पाठीमागच्या PPTमध्ये रिटर्न फॉर्ममध्ये दिलेलं आहे. तर प्लेन वेवफ्रंटचं कन्स्ट्रक्शन लिहिण्यासाठी तुम्ही स्पेरिकल वेवफ्रंटच्या कन्स्ट्रक्शनचा उपयोग करू शकता. फक्त स्पेरिकल वेवफ्रंटमध्ये ज्या ठिकाणी स्पेरिकल शब्द असेल त्या ठिकाणी तुम्हाला फक्त प्लेन हा शब्द टाकावा लागेल. स्टुडंट्स, देन वी सी प्रूफ ऑफ द लॉज ऑफ रिफ्लेक्शन ऑफ अ वेव ऑन द बेसिस ऑफ हायजेन्स प्रिन्सिपल. हे आर्टिकल जे आहे ते आर्टिकल बोर्ड एक्झामसाठी अतिशय महत्त्वाचं आहे, कारण या आर्टिकलवरती 3 किंवा 4 मार्क्सला क्वेश्चन विचारला जातो आणि रे डायग्राम 2 मार्क्ससाठी विचारली जाते. स्टुडंट्स, देन फर्स्ट वी सी व्हॉट आर दीज लॉज. फर्स्ट लॉ इज दॅट angle of incidence is equal to angle of reflection. That means angle I is equal to the angle R. Then second law is that incident ray, normal and the reflected ray are in the same plane. And for giving the proof of these laws, we must use the given image. For this image, first consider a plane wavefront AB, which is bounded by the 2 incident rays RA and QB. And this plane wavefront AB incident obliquely on the reflecting surface MN, that is by making some angle with surface MN. Then, according to Huygens principle, when this wavefront reaches on the surface MN at point A, then point A acts as a secondary source of light and emit secondary waves in the same medium because MN is reflecting surface. At the same time, waves from point B reaches to point C. Then draw the semicircle around point A with radius equal to BC then it is clear that when wave reaches from point B to point C, at the same time wave from point A reaches to point E, because point E is on semicircle around A with radius equal to BC. Therefore, point E and point C are in the same phase. Therefore, EC is a plane wavefront and it is a reflected wavefront which is bounded by the two reflecting rays AE and CF. Then draw the normal AP at point A to surface MN. Then we get RA is incident ray and AE is reflected ray, and angle I is angle of incidence and angle R is angle of reflection. Also from geometry of the figure, we can write in case of angle of incidence is that angle I plus angle PAB equal to 90 degree. Equation number 1, because angle RAB equal to 90 degree, and also angle PAB plus angle BAC equal to 90 degree, and this is equation number 2 because angle PAC is equal to 90 degree. From equation 1 and 2 or equating equation 1 and 2, we can write angle BAC equal to angle I, which is shown in this image. And also in case of angle of reflection, we can write angle R plus angle EAC equal to 90 degree because angle PAC equal to 90 degree. And also angle EAC plus angle ECA equal to 90 degree. Equation number 4. कारण त्रिकोणाच्या तिन्ही कोणांची बेरीज 180 अंश असते, त्यापैकी अँगल ई हा 90 डिग्री आहे. देअरफोर राहिलेल्या दोन्ही कोणांची बेरीज ही 90 अंश असली पाहिजे. देअरफोर वी कॅन राईट अँगल EAC प्लस अँगल ECA इक्वल टू 90 डिग्री. Then from equation 3 and 4, we can write angle ECA equal to angle R, which is shown in this image. Then in the image, we get two right angle triangles. One is triangle AEC and other is triangle CBA. And these two right angle triangles are congruent right angle triangles. म्हणजेच हे जे दोन्ही काटकोन त्रिकोण आहेत ते दोन्ही काटकोन त्रिकोण एकरूप काटकोन त्रिकोण आहेत, कारण अँगल E इक्वल टू अँगल B and these two angles are equal to 90 degree as well as side AC is common in both these two triangles as well as side AE equal to side BC. That is angle ECA is equal to angle BAC, कारण समान बाजू समोरचे कोण हे एकरूप असतात. Therefore angle I is equal to the angle R, and this proves the first law of reflection. Also from the geometry of the figure, it is clear that incident ray, normal and the reflected ray all are in the plane of the paper. That means all are in the same plane. This is the proof of laws of reflection by using Huygens principle. Also from this PPT, we can observe that when object is placed in front of plane mirror, then the right side of object appears as left side of image and vice versa. And this change of side of object in its image is called lateral inversion. Therefore, in this PPT, AB is seen as EC. Therefore, word ambulance is written in inverted manner on the ambulance vehicle so that other vehicle's driver can easily read it. Then we see laws of refraction of a wave on the basis of Huygens principle. स्टुडंट्स, हे सुद्धा आर्टिकल 3 किंवा 4 मार्क्ससाठी विचारलं जाऊ शकतं आणि यातील रे डायग्रॅम जी आहे ती 2 मार्क्ससाठी विचारली जाऊ शकते. सो स्टुडंट्स, फर्स्ट वी सी व्हॉट आर दी डिफरंट लॉज फॉर रिफ्रॅक्शन ऑफ अ लाईट. फर्स्ट लॉ इज दॅट Snell's law, that is mu equal to sin I divided by sin R, where mu is the refractive index of second medium with respect to first medium, where I is the angle of incidence in first medium and R is the angle of refraction in second medium. And other law is that incident ray, refracted ray and normal in the same plane. For giving the proof of these laws, we must use the given image. First, consider a plane wavefront AB as shown in this image, and this plane wavefront AB, which is bounded by the two incident rays A' and B', and this plane wavefront AB incident obliquely on the refracting surface Mn, that is by making some angle with the surface Mn. Then, according to Huygens principle, when this wavefront reaches on refracting surface at point A, then point A acts as a secondary source of light and emit secondary waves in the medium too, because Mn is a refracting surface. And if we draw a normal P' at point A to the surface Mn, then we get two angles. First is A'P, which is angle of incidence, and second is P'Ae, which is angle R, and it is the angle of refraction. Then we consider that V1 is the velocity of light in medium 1 and V2 is the velocity of light in medium 2. Then also consider that capital T is the time required to the wave which is emitted from point B and reaches up to point C. Then we can clearly understand that the distance BC equal to V1t as shown in this image. Then in same time t, waves from point A covers the distance equal to V2t. Therefore, draw the semicircle around the point A with a radius equal to V2t. That means when wave reaches from point B to point C at the same time, wave reaches from point A to point E. Because point E is on the semicircle, therefore point C and point E are in the same phase. Therefore, EC is the refracted wavefront. Then, from the geometry of the figure, in case of angle of incidence, we can write angle I plus angle PAB equal to 90 degree, because angle A'AB equal to 90 degree. Also, angle PAB plus angle BAC equal to 90 degree, because angle PAC equal to 90 degree. Then from equation 1 and 2, we can write angle BAC equal to angle I as shown in this image. Then in case of angle of refraction, we can write angle R plus angle EAC equal to 90 degree, and this is equation number 3 because angle PAC equal to 90 degree. Also, angle EAC plus angle ACE equal to 90 degree. कारण त्रिकोणाच्या तिन्ही कोणांची बेरीज 180 degree असते. Then from equation 3 and 4 we get angle ACE equal to angle R as shown in this image. Also in this diagram we get two right angle triangles. One is triangle ABC and other is triangle AEC. Then from the triangle ABC we can write sin I equal to BC divided by AC. कारण sin I is the ratio of front side to the diagonal side. But BC equal to V1T. Therefore, sin I equal to V1T divided by AC. Also from triangle AEC we can write sin R equal to AE divided by AC, but AE equal to V2T. Therefore, sin R equal to V2T divided by AC. Then divide equation 5 by equation 6 we get sin I divided by sin R equal to V1 divided by V2 because T and AC are cancelled and it is equal to refractive index of second medium with respect to first medium. That is, it is the ratio of N2 to N1. That is, N1 sin I is equal to N2 sin R, which is Snell's law. But if V1 is greater than V2, then from equation 7 we can write N2 is greater than N1. That is, angle R is less than angle I. That is, angle of refraction is less than angle of incidence. That is, refracted ray bends towards the normal when it enters from rarer medium to denser medium. And if V1 is less than V2, then N2 is less than N1. That is, R is greater than angle I. That means angle of refraction is greater than angle of incidence. That is, refracted ray moves away from the normal when it enters from denser to rarer medium. Also, during refraction, the image seems to be bent because the rays change their direction during refraction. But at the normal incidence of rays, there is no bending of the image. Thank you students for watching this video.